screen, it's showing showing ClickHouse team, isn't it? It's like, come on, show me. So we've got Dunith. I don't know, yeah, maybe we'll do some intros. Let's do some intros while we're waiting for people to join. So we've got Dunith in the blue. Do you want to introduce yourself, Dunith?
Yeah, thank you, Mark, and hi, everyone. I'm Donit Danushka. I'm a senior developer advocate from Redpanda. So I'm coming from a background in big data, stream processing, and real-time analytics. So yeah, I mean, it's nice to see streaming data platforms like ClickHouse and Redpanda make things faster and efficient in the streaming world. So yeah, thank you.
Cool. So yeah, so Dunith and I will be doing a demo of the two tools a bit later on. But we've also got Zach. Maybe do a quick intro to Zach.
Hey everyone, I'm Zach. I work with Melvin, Kelly, and Mark at ClickHouse, specifically on the product team. Mostly focus on kind of our cloud experience.
Cool. And then we've got Melvin.
Hello, everybody. My name is Melvin. I'm the product manager for ClickHouse core database. So my core focus is really about defining priorities for the roadmap for ClickHouse core. So the database in itself, not really the cloud product. So I'm working very much with the open source community to define these priorities. Nice to meet you all.
And then finally we have Kelly in ClickHouse colors.
Yeah, trying. Hi everybody, my name is Kelly and I'm in product marketing here at ClickHouse.
All right, so our plan is very simple. So what we're going to do, we're going to start off with a 10-minute update of what's been happening since the last cloud update call, which was about the first or second week of July. So we've got a couple of months and a bit. So Zach and Melvin will be doing that, and then Dunith and I will sort of show you how we can build a sports commentary copilot with ClickHouse and Redpanda. And then at the end, we're going to leave ourselves a section for any questions you have. But if you have specific questions for Zach and Melvin, we'll leave you a little gap after their bit. So if you have any specific thing that they show you, make sure you ask it there. But obviously, feel free to write us stuff in the chat or on the Q&A, and we'll do our best to answer it. Otherwise, I'm going to hand over to Zach, and let's get going.
Cool, thank you, Mark. So just jumping right in, we have a couple of really cool and exciting cloud updates to share with you today. Number one is our new Bring Your Own Cloud offering. So what exactly is this? I mean, it's pretty self-explanatory. This is, a kind of in trend in the market as we've discovered. And in ClickHouse Cloud specifically, BYOC kind of looks something like this. Basically, we deploy all of the compute and storage components to manage kind of a ClickHouse Cloud-like cluster directly in the customer's VPC. Right now, we support AWS. Basically, everything kind of related to the data plane infrastructure and any sort of storage resources, EC2 instances are all deployed within the customer VPC. Meanwhile, kind of control plane / web assets remain in the ClickHouse VPC. So you'll still do user management, authorization, etc., service configuration, all from the Cloud Console. But when you click the deploy resource button, those resources land in your own VPC. And kind of outbound traffic from your VPC to ours is limited to kind of health metrics and telemetry. That's the minimum necessary for us to kind of operate your cluster remotely. So what are some kind of key points here? Number one, some organizations obviously have incredibly strict PII data protection guidelines that they need to meet. In this kind of deployment mechanism, all of your kind of data lives within your VPC. Also, kind of total cost of ownership. A lot of organizations have their own, very, very beneficial agreements with various CSPs that include carve-outs for discounts on specific types of resources. And these kind of discounts can be leveraged in order to kind of bring down your total cost. Additionally, if you've got kind of additional components, say like an OLTP database or apps that are backed by ClickHouse. Those can run also kind of within the same VPC, so you'll kind of save on network related costs as well. And then finally, we've got a couple more performance predictability. Obviously, if you're deploying your own EC2 machine types, basically you have incredibly predictable performance and throughput. These are not necessarily guaranteed in our kind of multi-tenant cloud. Basically, hardware is deployed as it is, based on availability. But within your own VPC, you can deploy whatever it is that you want. And then finally, controlled upgrades. Basically, we'll work on your schedule to deploy kind of version upgrades to ClickHouse or to our kind of underlying data plane infrastructure. So they'll be totally predictable, and you can kind of work to avoid and minimize disruption as you so wish. Currently, BYOC is in private preview. You can join the waitlist at the link here, clickhouse.com/cloud/bring-your-own-cloud. Again, it is currently limited to AWS, but if you're interested in AWS or any of the other hyperscalers, please still join the waitlist, and our sales team will engage with you to iron out next steps. All right, so that's one of two. The second is compute separation, and this is available in private preview in ClickHouse Cloud today. What does it look like exactly? Basically, in the current ClickHouse Cloud architecture, you can have a single group of replicas, and you can horizontally and vertically scale them as you wish, and they connect to a singular keeper cluster and S3 prefix. But there was kind of previously no way to isolate resources from each other that are reading from the same storage. In this new kind of compute separation architecture, you can deploy multiple replica groups that are all backed on the same S3 prefix and communicate with the same keeper cluster, but they can be scaled horizontally and vertically independently of one another. And they each get a discrete endpoint, so you can fully kind of isolate different workloads. Additionally, we do support different categorizations of replica groups. You can have read-only replica groups and also read-write groups as well, based on kind of your workload needs. So key points here, again, in scenarios where, for example, a customer has different business units that all need access to the same data. Each business unit may have varying kind of performance and cost requirements they need to meet. Compute separation guarantees this, and it also means that you have no noisy neighbor problem, between business units. So, for example, if you've got like a real-time customer-facing application and the team that's managing that, they don't have to worry about resource starvation because the data science team starts running heavy ad hoc analytical queries. Secondly, isolation of reads and writes. Sometimes, the most business critical function is actually the ingest workload, and that can never be interrupted. So by isolating reads and writes, for example, you can ensure that your ingest workload is never interrupted, and kind of in parallel, reader groups can potentially scale to 0 independently when not in use, to save on costs. And finally, kind of alluding to number 2 again, each replica group can scale horizontally and vertically independent of one another. So in effect, based on your high availability, performance, or cost requirements, you can fully right-size your resource allocation for each workload that you want to run on top of the same data. And compute separation is already in private preview. Here's a link to the documentation. And if you want access in private preview, please reach out to our support team. And with that, I'll hand it over to Melvin.
Thank you, Zach. So yeah, we're going to talk about one big feature that was awaited by a lot, which is called JSON support. As you probably are aware of the history of the feature, if you can go to the next slide, you will see that this is a feature that I've been cooking for quite a long time. We have been working on it for, I guess, maybe more than 1 year, actually. I don't know if we can go to the next slide. Yeah, so this feature has been cooking for more than 1 year. We had a first version that did not really pay off, and we created a much more reliable implementation, which we released in 24.8. and we introduced it as an experimental feature. It relies on many different building blocks, including dynamic data type, variant data types, in order to make sure that the feature is working efficiently and really can match your scenarios of I have raw JSON data and I want to insert them into ClickHouse and not having to care about creating my schema ahead of time or having like a very strict schema, so your schema can be a bit loose. So it's ideal for semi-structured approach and when you are dealing with raw JSON data. Now, if you go to the next slide, you will see that it's available in the open source right now as an experimental settings, but we also have a private preview in our cloud. So if you want to test it out in the cloud, you can. You just need to join this private preview. This is ideal if you want to test the feature and prepare for for its general availability. We are working towards making it GA. So this private preview also help us collecting bug, usability improvements, and it's not designed for production workload. So yeah, like we try to work with people that don't rely on it for production or for critical workload. And if you want to be part of this private preview, please feel free to reach out to the support team, and we can add you to the list and discuss with you if you want to be testing this feature with us. Great. Handing over to you, Mark.
Cool, thanks. So we have some questions. At least one of these is for Zach. So the first question is, does Bring Your Own Cloud require VPC peering, or can you use AWS Private Link?
You can't use AWS Private Link. I think basically we use kind of CloudFormation to create an IAM role, and that's how we kind of communicate with stuff in the customer VPC.
Okay, cool. And then the second question, which I think I know the answer, but let's try anyway, is there any news on CDC for MySQL? I don't know if that's in your, if you know the answer to that, and either of you, but let's try.
That's something
Yes,
we are. Oh, sorry, go ahead, Zach.
No, you go ahead, Melvin.
I was going to say that's something that we are now we recently acquired like PADB to improve our PostgreSQL CDC pipeline, and let's say that MySQL is very high on our priority list.
Cool. But first, they're integrating Postgres. Maybe after that. Some people asked, hopefully the compute doc link, you've got that, Ramazan. I think that's all. I don't think we had any more questions, but yeah, feel free to post any more on here, and if and we will ask them when we get there. So should we switch over to me, Zach? Do you want to give me the power? Right, let's share my screen. Great. Okay. Let me see. So, Dunith, can you see the screen?
Yes, you're good to go. I can see.
Success. Let's go. So, this is a talk, as you can kind of see. So, Game Set Match, transforming live sports with AI-driven commentary. So, the idea for this came. So, Dunith and I often we chat quite often, and we often talk about like how would Dunith sort of drives this, but when you see like things that are being done, like real applications or things where technology is used, how do you think they are actually built, or how could you go about building them yourself? And so one of these that we were talking about was live sports commentary. So this is I guess this is a little bit dated now, because this was when Djokovic won the US Open in 2023. And we were talking about how in the UK, at least, and I guess maybe that you have similar in other countries, the BBC often do these live text commentaries. So it's basically for people who don't want to pay Sky Sports or ESPN or whichever provider has all the coverage to watch it live, or they're busy and they want to just see on their phone, okay, what's roughly going on. And so the BBC do this live sort of commentary. So it kind of has stuff like this. Sort of and so some of it you look at it and you're like, okay, really is like some specific knowledge from a person. You can see sometimes they're bringing in quotes from the live commentator who's commentating on the radio. Sometimes it's coming up with quite interesting insights, and sometimes it's just more or less summarizing what events happened in the last couple of minutes. So like say this one down here, a double fault, 30 all. It's quite generic. And so we were thinking, like, trying to imagine, well, what is life like for this commentary writer, and could we make it better? So we were trying to think, like, okay, well, could for some of this commentary, there's some skill, like, hey, I want to write something really cool, and for some of it, you're sort of like, yeah, can I just get the AI to help me summarize what happened? And then we were thinking even further than that. They often will do commentary only on one or two courts, but if you had like a helper, could you then go and do commentary on like 20 courts, or like, and sort of stretch the amount of stuff that you could cover? So I go hand over to Dunith now. He's going to talk us through what we're going to show you.
Yes, Mark. So thanks for the introduction and setting the stage. So I think the picture is pretty clear. So basically, what we are going to build is an AI-assisted sports commentator. So basically, we are going to feed live tennis scores into this application, and application in return, it will provide us with live commentary based on the live scores. So this will make sports commentators' job more easier, and it will reduce his efforts and time when it comes to managing multiple sports events at the same time. So this is basically the solutions architecture of the solution. I know it's pretty too early to go through each solution in deep, but let's try to follow the data flow. So the data flow begins from left to right. So in left, we have a Python sports data feed. So ideally, in an ideal world, this could be an sports data provider, something like ESPN or any sports API that would have real-time streaming of match data. So this could be cricket or tennis or football or any sports that could think. But the problem is, for this webinar, we couldn't find any live tennis match going on. So it's really hard to find a appropriate match. So what we thought of producing a synthetic load of a given tennis match. So we have written a Python script to make the simulation. And then once the script runs, it will produce a stream of JSON formatted events to Redpanda. So don't worry, I'll talk about Redpanda in a few slides later. But for now, think of it like a message bus, streaming data platform. The reason why we included Redpanda in this solution is to add more scalability to the solution, as well as introduce decoupling, because this will be like a bus, so that you can plug in more intuitive components as the architecture evolves. Basically, Redpanda ingests these streams of the live scores from the Python. In real world, it could be sports API. And then it will be, this ingested data will be moved to ClickHouse. So we have a connection over there. So Mark will walk you through the ClickPipe, setting up a ClickPipe to make this ingestion smooth and streaming. And then whether we have familiarity or not, we have a large language model, OpenAI as our large language model. And then we'll use a front end. So basically that's the screen you saw in the previous screen. So this front end is the screen where the sports commentator will be working with. And we used a Streamlit Python-based UI framework to build this front end. And Streamlit will communicate with ClickHouse and query the data. It will gather the most relevant and up-to-date data and pass it to the OpenAI to get the necessary summarization done. And then finally, the generated commentary will again be published to Redpanda topic, and it will be synced to or broadcasted to different web application, which we'll cover in a different slide. For now, this is the very high-level architecture of the solution. Okay, let's talk about Redpanda first, and then we'll move on to ClickHouse. So basically, Redpanda is a Kafka API-compatible streaming data platform. Designed for low latency, high throughput data ingestion. Redpanda is not just another Kafka fork, it's a Kafka rewrite in different language, C++. So because of this rewrite, Redpanda has more performance, cost efficiency, and other simplicity factors compared to traditional Kafka deployments. Next slide, please. So when it comes to Kafka API compatibility, what I meant was, if you already have a Kafka producer or a consumer, you can seamlessly move that producers or consumers to Redpanda, basically making it a drop-in replacement for your existing Kafka workloads. Having said that, Redpanda has several significant benefits over Kafka. For example, it's an operator's best friend, I would say. So basically, in a typical Kafka deployment, you would see different components you need to deploy and manage separately. For example, in a typical Kafka cluster, you need to have your broker, your schema registry, a HTTP proxy, differently deployed and managed. But Redpanda comes as a single binary, and it will bring all these processes in a single runtime. So what does this mean? This means if you spin up a Redpanda process, it will bring all the processes together, like the broker itself, the schema registry, and the HTTP proxy together. That will make your life easy as an operator because it comes with Helm charts and other CI/CD and GitOps friendly, all the templates and whatnot. Next slide, Mark. And then it's a developer's best friend as well, and it will bring all the ecosystem tools to make building large-scale event-driven applications easier. What you see here is a screenshot of Redpanda console, which is a rich web application which allows you to manage your Redpanda cluster. So basically, as a developer or operator, you would manage and work with your Redpanda cluster through this interface. As a developer, you would create topics here. You can also browse your data, which Mark will show you in a minute. And then also you can see and work with the embedded schema registry as well. And then you can define your ACLs. You can define your fine-grained access control policies. And there are many things you can do with this Redpanda console. We'll have a nice walkthrough when we get into the demo. Next slide, please.
Got a question for you, Dunath.
Yep.
Can we, well, it's a two-part question. So can we use Redpanda Connect to insert data into ClickHouse instead of using Kafka table engine? If so, does it support the exactly once processing semantic?
Yeah, that's a good question. So Redpanda Connect comes with ClickHouse connector, if I'm not correct, if I'm not mistaken. Yeah, I mean, exactly once is a design semantic, so we have to implement. So yeah, the support
Yeah, I
is
mean,
there.
on the ClickHouse Kafka engine, there's like a new sort of more experimental version of it that does allow you to achieve the exactly once processing of messages from, for example, from Redpanda. But what we're going to show in this talk is actually not the Kafka engine. It's like a ClickHouse Cloud specific version of processing data from streaming engines.
Yeah.
Hopefully that answered the question. Should we go on? Do you want me to go on to the next one?
Yes, please.
All right, there we go.
What we missed here is the RPK. Basically, it's a CLI tool. It's something similar to, but more versatile than KCAT or KafkaCat. So basically, this is a CLI that allows you to work with your Redpanda cluster in a programmatic manner, so that you could do some administrative tasks, developer tasks, something like creating your topics, defining policies, and debugging your topics data. So those kind of things you can do with the RPK tool. So simply, RPK stands for Redpanda Keeper. So you can also make it programmable by embedding RPK commands in your GitOps or CI/CD pipelines. When you script certain things, you can include RPK. So that's the goal of RPK. Moving on to the next slide. Okay, I think that's time for demo. Mark, you
Right,
wanna
let's have a look. So, oh, not yet. Let's not skip there. So, let's right. So I am using a version of Redpanda serverless. So let's just quickly, just so you know what, and I'll let Dunith explain this. But
Yes,
when you, so where do we go? Hang on, we've got, where do we get the overview of
you
all the
can go
things?
to cloud. You can,
Yeah, overview there.
yep. And then
Cool. Which
basically
bit?
the
This
easiest
bit.
way is you can type on cloud.redpanda.com and it will bring you to the serverless, the cloud, so
Yeah, no,
Redpanda
I've got it
cloud.
here,
Yep.
but I was trying to show like the page where it compares all of them. Like, where does it do the comparison?
Yep.
So I went through here.
While Mark going through that, I'll
Mm.
give you a bit of introduction to Redpanda serverless. So basically, Redpanda serverless is the easiest place to get started with Redpanda if you don't want to manage anything uh, locally. So it offers you fully managed offering with and allows you to create a cluster literally in few seconds, and also has a usage-based pricing, and you can only pay for what you use with true scale to zero. That's a nice thing to have. And once you sign up with your identity email, you will get a 14-day free trial to experiment with Redpanda serverless. Other than that, Redpanda provides support for BYOC, dedicated, and self-hosted deployment options as well. As a community edition, we have Docker Compose-based deployment for community as well.
Yeah, so you can kind of see that I have still got 3 days left. So I've spent $4.85 in my 11 days playing around with Redpanda serverless. So what you get when you launch it is pretty much what you can see here. So they will have a welcome cluster running for you. I think when I created it, I chose where I was. So it's put it in the EU in AWS. And then I can sort of click through and then I get an overview of my cluster. I guess I could create my own one if I wanted. You can sort of
Yeah.
see what topics are there. So you see it comes kind of pre-filled with a hello world topic with some, you can kind of see there's some text in there, no key, but it's got a bunch of different values, kind of talking you through how you might create a topic and put some data in there as messages in Redpanda. So it's very meta. Now, what we want to do is we want to create a couple of topics. So we're going to be using two in particular. So I'll give it 3 partitions and I'll create that. And then we're going to create one more in a minute. So you see it finishes. It says, hey, I've got my topic here of partitions is default and replication factor is 3. Let's create one more. So these are 2 that my application needs. So Dennis can correct me, but from my experience, you need to have these topics created beforehand if you're using Redpanda Cloud or serverless. If you're using, at least when I've been using Redpanda via Docker, it will create it if you don't already
Yes.
have it created.
It has a flag, a configurable flag, so you need to set it. I mean, if you by default it sets to true. That means even if you haven't created it, it will create it for you.
Jana says you've only got a couple of days left, just enough time to finish an MVP. Yeah, let's see. We've got to do our MVP in the next 20 minutes. Let's
It's
see
a
how we do.
generous
Yeah.
trial, I would say. So yeah.
It's going well so far. Right. So we can kind of see if you click through to the topic at the moment, we don't have anything in there. So our job is to put some data in. So let me show you what we're going to ingest. So if I come over to my console. So as Dina said, I basically got a bunch of data from the US Open live commentary feed, and they effectively have, like as HTML, a breakdown of what happens point by point across a bunch of tennis matches. I can't find it for this year, so I think there might not be that feed, like ability to get that might have gone, or I can't find it. But so this is 2023, and you can see how I just kind of like did some CSS selectors and found what exactly they had. And so you get an ID sort of representing the point. It tells you what time did it happen, the players. So generally player 1 and player 2 will stay the same for the whole match. We've got the previous set score. So in this case, this is the first point of the match. So there's nothing, who's serving, and then the score and what happened in that point. And so what we can do is we've got this. We then need to get this into Redpanda. And what I've got in my publish events app, let's just have a quick look. So this is basically this is purely of interest for simulating, but we've got this twisted app in Python, and it's basically creating an event loop, which is, I don't know what happened to my video. I'll see if I can fix it in a minute. And it's basically just going over all those events that we saw in that JSON file and working out from the timestamp when they should be published. And then we've kind of got a loop going on every second, and then it chooses which events should then be pushed to Redpanda. Now we are using the I think it's called Kafka Python, the Kafka Python library. And so you can kind of see the sort of stuff that we had to set up. So we've got our Redpanda broker location. Because we are using it in the cloud, we've got to say what protocol are you using. So we're doing SASL, SSL, and then what mechanism. Now you can choose 512 or 256. I think I chose, well, I definitely chose 256, but I think you choose this when you initialize your cluster, or maybe I definitely did it somewhere. I did it somewhere in the Redpanda UI, and then you can give it a user. So I've created a user, and you can see I've got that available as RP user, and then I've got a password as well. And the rest, you can kind of see above. This is what it would look like if you were doing it on your own machine. This just reminds me that I forgot to show you a little bit of the UI. So if you go onto your overview, it sort of shows you how you could go about using the Redpanda Keeper tool that Dunith explained on the last slide. What it also shows you is if you click on Kafka API here, you can then choose for which language driver do you want to use. So for example, I would maybe use Python. And if you need to get a copy of your server URL, so like if you wanted to paste it in to your application, you can get a copy of it there. And then you can see if you click on Python, it kind of gives you nice copy paste code. So I could copy that code and it will set up a virtual environment for me. I could then, if I hadn't already created my topic manually in the UI, it would then give me the code to do that. And then I can kind of scroll down and you see this is very similar to the code that we've got in our Python file. And then you've got code to, sorry, go on.
Yeah. Sorry to interrupt. Since you mentioned about writing a Python client, I think the best library we recommend you to use is Kafka Python /ng. Sorry, -ng. So it's the NG stands for next generation. Kafka Python used to be the traditional one, but it's no longer maintained. So we recommend you to use Kafka Python -ng. NG. Yeah.
All right, we have to get this page updated.
Right.
All right, let's come over to here. So what we're going to do, we're just going to go out of that file, and then we're going to run this script, which is going to, so you sort of see it kind of goes through the points. We've sped this up. This match took 4 hours, and we're not going to wait here for 4 hours. So we've kind of got it going at about 10 times speed. But you can kind of see some events have gone through. If we come back over here, I'm just going to click on my topics link. On the left-hand side, let's just refresh that, and we'll click, and you can kind of see some events have come in to points. You see that's up to 16K. If we click through, you can see that we've now got the data in here. And what you can do in here, so you can kind of see what timestamp it has. You could choose to expand the timestamp. You could look at the key, so you can see this. The key is the ID of each of our messages, and so we put that through as the key into our producer. And then we've got the value. This is exactly the same as what we saw on the command line. Now we are loading JSON. So this is just a JSON object. If you were doing this in a production application, probably you're going to use Avro or Protobuf, and you might then make use of Redpanda's what do you call it, schema. Like so you would use their schema registry.
Yeah.
The benefit of that is that if you then change your schema, so say we add in an extra column, it's going to know about that change. Or if you remove something, it's going to, I guess you're going to be able to handle that more cleanly than if we just have, okay, there's some JSON, there are some keys. But for quickly getting started and for doing a demo like this, JSON works pretty well. Is there anything else we should show about Redpanda so far, Dunith, that I haven't mentioned?
No, I think this is good so far.
All right, cool.
Probably you could walk the audience through the ACL section, security.
Oh yeah,
That's,
so that's the other thing we've done. So we created ourselves a user. You see, I've already got my user, but what you can do, so you create a user, new user. This is where I chose my mechanism. So yeah, you choose your mechanism, create your user, and then you can create like what access should this user have. So what did I do? Did I say any? Or did I? Yeah, so you can
any, yeah. It's
create it
like
here. What do I do?
wildcard.
Choose I can do it for a new user here.
Yep.
It's my Dunith user. And then I can sort of choose what do I want Dunith to be able to do. So it's like he's then going to be allowed to.
So it gives
read.
you fine-grained control, access control. So you can restrict certain users accessing certain topics, or you can allow them to access all the topics. Mark, another nice thing would be the connector screen, if you can quickly take us through. So basically, Redpanda serverless comes with built-in native connectors like Snowflake and popular connectors to popular sinks and data sources. So you can pick and choose where you can ingest data from as well. That's it. Yeah.
Cool. So do I have to type, what do I type in here? Is YAML or something in here?
Yeah, so we'll leave it for now.
Okay. Skip that. Right. So now we're going to look at how do we connect this to ClickHouse. So I'm going to come over to my ClickHouse cluster, very imaginatively named Mark's ClickHouse cluster. And so when you're on data sources, as Dunith mentioned before, we can create ourselves a ClickPipe. So this is sort of a continuously running service, if you like, that will ingest data from different places. When we click on it, you can see these are all the options that we have available. Oh, look, there's a new one. We got Postgres CDC, at least on my one. So that's a new addition. And then what we want now is we want to click on Redpanda over here. Now it's filled in some of this stuff because I've been using it throughout the day to just check it works. But what we need to change is we need this to be 256. It's got my user and password, but we need to get our Bootstrap server. So let's just copy that and we'll paste that in here. I think that looks all good. So we've got our pipe, we've got my name, we've got the SASL mechanism, and I think we're good to go. So we can click next, incoming data. And that will then take us to here, and it says, hey, I've identified some topics on Redpanda. We'll say I want points. We can then say, where do we want to read from? So I guess from the beginning, but you could choose from a timestamp or from the latest offset, but we'll get everything. And then you can see it's now loaded, which I guess this message, which we are getting very familiar with. If we click on that, it's now going to pass that and attempt to create a schema. So you see it's saying, I'm going to put it in the default database. I'm going to call it points. And do you want to choose a key? So usually when you're putting data into ClickHouse, you want to choose a sorting key. And usually it's going to be based on what type of queries are you going to be doing? Are you going to be filtering on a particular thing? Are you going to be aggregating a particular thing? For us, probably, I mean, the amount of data we're loading is very small, so it doesn't really matter a lot, but we're probably going to be filtering up. We're interested in doing queries based on matches. So let's put it as matches, as match ID rather. And then we're going to come through. Now it makes an attempt to guess what it thinks the types of each of your fields or columns should be based on looking at the data that it's seen. Now sometimes, and most of the time it gets this right. In this case, I know that some of these need to be a little bit different. And I can also choose to exclude some fields. So for example, potential published time, I don't really need it. It was just used in the generator. And published, I don't need it either. So I can click on the X and you can see those are now, well, they're even more gray than they were before, which means that they are excluded. The other thing we need to make sure is that time is not actually a date time. So we just need to tell it that it's not a date time. Other than that, I think we are now good to go on to the next step, details and settings, which is where we choose the permissions for our ClickPipes user. So I'm just going to simplify my life and give it full access. And I can then click complete setup once I'm done. Now you can see I've got some previous data that I've loaded. So this was stuff I was playing around with before. But now our ClickPipe, our points pipe, has appeared underneath the ClickPipes section. And you can see it's currently provisioning. And so that's kind of getting it ready to load the data from Redpanda. That seems to now be running. And you can see it's loaded 223 records. We can do a little preview and you can see the data is now loading in. I'll close that. And then let's click through to view table. So this is in a table, as you can kind of see, called points. So you can sort of see the data is all loaded. We can click on points and see the schema over on the left-hand side. We can also get a bigger version of the schema over on the right-hand side. So I right-clicked and hit view schema. So you can see it's telling me this is for interested if you're interested in sort of what's going on underneath the hood of ClickPipes. It's telling us I've got my sorting key. I've loaded 229 rows. I'm using the shared merge tree. So that means it's using the merge tree, i.e. appending stuff, but it's working across a cluster. What's this question? Can I choose the codec? I went through that quite quickly, so I'm not sure. Maybe I could definitely have chosen whether or not I wanted to apply transformation to each column, Ramazan. So sort of asking how much control you have over the create table. Maybe we'll look at that again after we've sort of worked through this to see if there's a bit more control that we can get. But you can kind of see what it's come up with by looking at the create table SQL. You can then sort of, if you want to do stuff in SQL, you can obviously do that as well. So we could say, hey, describe points and get more or less the same sort of information as what we just saw, but as our own query. And we could say, okay, I want to do a select count. I don't know, just a simple query from points. And we can kind of keep on playing around with this query. So you can see there's now 270. It's still processing information. So you can see we're now into the third set. So we could order by publish time descending and say, I mean, this is probably fairly unlikely we're going to do this on normally select star, but just so we can see, this is the latest point that we're up to. And you can kind of see the score. So we're in the fourth set and it's 4-1 to Djokovic. Now we can kind of keep on playing around with it in there. But if we want to have a user use this, we're going to want to build some sort of front end. So let me just come back over here. So skip that, skip that, skip that. So as Dean has mentioned before, we're going to be using Streamlit. So in case you've not seen Streamlit, the idea is roughly, can we take Python scripts and make shareable web applications very quickly? This is an example of what a very simple web application would look like. We're now going to look at how to build it. So back to Dunith's diagram. Remember, we started with the sports feed on the left-hand side. We've got that data into Redpanda. We then put it into ClickHouse, and we've now had a look at doing some queries on there. So the left-hand side of our diagram has been so far successful. We're now going to have a look at how do we do the bottom part of this, so the generated commentary. So I've got a Streamlit application already running. We'll share all the code that we're doing in here, but let me just come over to another tab, and I'll run the Streamlit commentator app. It tells me, hey, I'm on 8501. Great, let's open that. So this is what we get. And so imagine like the user could say, hey, this match is amazing. Maybe don't write that on the live commentary, but we can then publish that. And you see it says the message was published. And so what happens is that then goes over to Redpanda. If we decide, oh, I don't really know what to write, we could come and ask the AI to help us out. So we can ask it, show me what happened in the last 5 minutes. It's then making a call to an LLM with the data from the last 5 minutes, and it will then come back. And so you see it then generates this message. So what does it say? So after losing his break early in the 5th set due to a forehand error, Jarrett is trailing, who's by to Djokovic, who's dominating the match. Blah, blah, blah. Djokovic powers through, leading 5-2 in the 5th set. Now, it's been given like a bunch of events for the last, It's effectively the last 60 seconds, and it's running at 10 times speed. So it's kind of giving it 10 minutes worth of stuff. So that's how it's able to come up with this. And we can then publish it. As I say, we could then write in our own message. We can give it a title, Djokovic, comeback, almost complete. Could send something like that. Djokovic is going to win this. And I could sort of send that off. And then if I want, I can also choose to say, okay, I just want you to use the last game's worth of data. So this is going to be, if you were eagle-eyed, the match is now finished. So this is going to be the last game of the match. So it's sort of going, get the events for that last game, send it across, and you can see it sort of going after an intense battle lasting over 3 hours 45. The reason it knows that is because we've given it the match time, like the time that the event happened, and then we can kind of click use that message and publish it. Did I publish it? Yeah, I did. And if we then come over to our Redpanda page, go back to my topic, and then this is then refreshing onto the other topic, so live text. So you see, what did we do? What are we up to at 46 past? So you can see an intense battle. I think I sent the same message twice. Yeah, I did. So I missed the notification on the first one, but you can see that those messages are then making it into Redpanda. So we've kind of gone data streamed into Redpanda. We went down to our application. It went off and did some cool stuff with OpenAI, got back to the data, showed it to the screen. The editor was like, hey, yeah, that looks good. Maybe I do some typing changes, and then sort of sent it over. So I want to just quickly explain what exactly was going on that page. So what we did was relying on large language models. This is the simplest possible explanation. So large language model, more or less, ChatGPT, we've got a prompt, we write something, it goes to the LLM, it gives us a response. Now, if we were to give it like, hey, I want you to tell me what's going on in this Djokovic-Jera match, it's going to be like, well, I have no idea what you're talking about. I'm probably, my data cutoff was either 2021 or 2023, depending. And even if it does know that there was a tennis match, it's very unlikely that it remembers every single point that happened. And so what we need to do is insert some context into the prompt. It's kind of a version of retrieval augmented generation, but we're not using vectors anywhere in this process. Now, this is something that you can, like if you wanted to do real-time RAG, this is something that you can do with Redpanda Connect, which was a question Ramazan was asking before about things that you can do with Redpanda Connect. So we could actually create ourselves a pipeline where we're taking text, creating embeddings and storing that in ClickHouse with Redpanda Connect and ClickHouse. But in our example, we're actually doing something much simpler. So we're basically saying I've got my instructions of what I need the prompt to do. I've got my context. Now the context would be where you'd normally do your vector lookup. But in our case, we just know, okay, well, I'm just doing a SQL query to get some data, and then I'm sticking that into the prompt. So it's reasonably simple in the terms of what you could do. Now, what we're actually putting into the prompt is we're basically putting in like this sort of JSON structure. Now, if you try to do this with a local model, like a local 8 billion parameter model, it will generally have no idea what to do. This is too complicated. But for the big frontier models, if you do with Anthropic or do OpenAI, or probably with Llama 3 400 billion parameter model, or even the Mistral large, it's going to work. It's going to figure out what this means. If you're using a smaller model, we might need to narrow down the data that we're giving it and maybe make it a bit more explicit. And then this is what the LLM code looks like. It's nothing, this is not super complicated. We're giving it a system message where we're telling it, basically telling it what are we trying to do. And then we're calling the OpenAI client and we're saying, here's the system message, here's the user message, and the user message is those events as a string. And then this is what our ClickHouse pulling code looks like. So again, pretty simple, call something to the ClickHouse host, put in the query, convert our events that we get back into dictionaries, pass it into OpenAI. And then as you've seen, like this is the sort of thing that it comes up with. Just to show you quickly the queries, I wouldn't say by any means these are hard queries on the amount of data we're working on, right? Like ClickHouse is generally good for doing aggregated queries on lots of data. I mean, we're working with like a few hundred rows, so keep that in mind. But as the data got bigger, and maybe as we extended the types of user things that we're doing with this app, we could probably do things which are more needed, more where ClickHouse and Redpanda can work at high volume. But yeah, these are the queries. So we're doing a join query here to find the last the last game and then join it to find, well, what were all the other points in that game. So I'm going to hand back to Judith just to explain what are we doing with now that we've got the live text into Redpanda.
Yes, Mark. Now we have the raw data, and then we derived live commentary from that raw data, and we now have the generated commentary in live text topic. So what can we do from this live commentary? So before answering that question, I like to remind you that Redpanda or Kafka API. So basically they are publish, subscribe system. So basically live text is a topic. This means there can be multiple consumers to this topic at the same time. So there can be concurrent, simultaneous subscribers. So in the context of sports event broadcasting, I think the most practical way is to take this data and stream it to some kind of a web or mobile application. So I think that would be the most sensible approach. In order to facilitate that, we can have a consumer. Now the problem is how we can stream this data in real time to not a web application or mobile protocol, which is not really Kafka API compatible, and it's outside the firewall. So in that case, we need to bridge this gap by introducing some kind of a intermediary protocol like server-sent events or SSE. So what we did was we put Fast API, which is a SSE server in the middle. So Fast API can consume events from live text topic, and it can convert those events into SSE events, and they can stream it to this web application. So this could be either web application or mobile application. Whoever interested in receiving this could contact Fast API, and then they can receive this streaming. And that's our primary use case, but we don't stop from here. So there can be many possibilities. For example, you can also write some kind of a client or consumer that calls this live text and post it to social media platform like X. So this could be like 5 minutes match summaries or 10 minutes match summary. So there can be endless possibilities. And like Mark mentioned, and there was a question before, you can also write some transformations or some kind of a live streaming ETL pipeline in Redpanda Connect. So these are like declarative YAML data transformations. You can also take this live text and sync it to some kind of analytics infrastructure, something like a data warehouse or data lake for later analytics for data scientists and exploratory analytics. So yeah, I think there are many possibilities because this is a pub-sub system.
Yeah, let's have a quick look at what this does. I appreciate we're getting a bit close to the end, but
yep.
Again, like the code that we're using here, we're gonna share it all so you can grab it. But I'm gonna run the server for now. So what if we then come over to my browser, let me just close that. So as Dean had said, what this is doing is it's basically creating a consumer that is sort of going over all the events in the live text topic, and it's sort of streaming them out. So if we let's just do a split here. So if I write like Djokovic is, oh, whatever, I can't type. Djokovic is the best. Hit to publish. You see that comes up on here. So it's gone through Redpanda and then back out the other side. If I put, well, a good try by Jera, something. So publish that. Then you see that now comes out the other side. Now, what you can then do on top of that is we could simulate like a front-end application, like the BBC Live Text. So we've made another Streamlit app, and this one is again consuming from the SSE server. So hopefully we should be able to see these events coming through. So if I wonder whether I can get that one to come over here for me. There we go. So this is not all right. So hang on, let's get this to the bottom. Go. Let's just hit that. I do it. Oh, there we go. Got it on the left, got it on the right. So there you go. So that's coming all the way through from Redpanda to, in this case, to Streamlit, back up to Redpanda, over to the SSE server, and then back out to Streamlit. So we had a couple of questions, but before I answer those, let me just show you where the code is. What should we do? Yeah, so I mean, we just want to just quickly run through some ways to extend this. So you can kind of see, like, maybe we can automate this a bit, do summaries every second. Maybe we need to give the Copilot access to fine-grained stats. Perhaps we don't even need to use OpenAI, and we can make use of Redpanda's sovereign AI, and they've got some stuff integrating with the Llama. So that could be cool. And you can see some other ideas on there as well. We could also go beyond that and do that for other things. So anything where you see, like, there's yeah, like you're generating like information about some kind of, I suppose, kind of dry like stuff, like, oh, the weather, or live auctions or traffic reporting. Like, can we make it a bit more interesting for people to consume? And then Dunas wanted to just, I'll let you talk about this for, yeah, we've got about 3 minutes. So yeah, just do it quickly.
I'll make it quick and short. So basically, so this is about an announcement I would like to make about upcoming Redpanda hackathon. So this is a call for all AI and data enthusiasts out there. So you can check further information on this QR code. So basically, in this hackathon, we'll give you a challenge, and you can implement this challenge using Redpanda and Redpanda's AI and other Redpanda ecosystem components. So it's an open invite for all the developers worldwide. So the hackathon date is September the 30th. So you can register yourself now on, and you will stand a chance to win up to $5,000 and more. That's it. For more information, scan that QR code. So.
Yeah, there's the QR code. We'll show you the slides as well, so you can grab this. And then this is where the code is living. We had some questions. Let's see. I've got a few minutes. So, Jana, what optimizations would you recommend for reducing latency in real-time queries? So the main sort of idea, which we've seen works pretty well at very large volumes, is we use materialized views into tables. Now, remember, the materialized views in ClickHouse are a little bit different than ones in other databases, where it's almost like you could consider it a bit of SQL that gets triggered when you get a batch of inserts coming in on the table. So you sort of set up a materialized view almost to listen to a table, apply some SQL, write it somewhere else. So we've got quite a nice example of that on a couple of demos that we've worked on. So, or that my colleague Dale has worked on, rather. I shouldn't take credit for his stuff, but there's one called ClickPie. So if you do clickhouse.com, or if you look for that on GitHub, that's like a really good example of, well, how do you break down this sort of really big table with a trillion plus rows into something that I can query to answer different questions. So I'd say that's sort of roughly the idea. Kelly's answered one of these live. So does bring your own cloud also have shared merge tree? So the answer to that is yes. And then we have another question. I don't know the answer to this. We might have to answer it later. So do you have an option to use EBS? The EBS instead of, I'm not sure, instead of what? Is that, oh, sorry, specific to bring your own cloud? I think we'll have to ask Melvin or Zach about that one, because I don't know the answer. But if you have any other questions for me and Dunith, I think we've got one more. How do you guys see ClickHouse testing this tooling, or are you seeing this as a future service or just an example? So interestingly, when we did this talk before, someone came up to us, and we did this talk in person a few months ago, and someone said, "I'm actually doing exactly the same thing as this, but for another sport." So I think the idea is of doing this like fine-grained sports analysis. I think it is common. The tricky thing which we found is that data is very monetizable. So like IBM basically have a lot of the data, or Opta have a lot of the data, and they basically sell it. So you've got to be able to put down like 20 grand, or if you want to be able to get access to the proper data, but they must have like way more fine-grained than what we're doing. Like, so within a point, there are shots, right? Like we're only getting the point, which often takes, between 0 and 30 seconds. But within that, there are way more data points of what's happening. And they have like the location of people on the court, Like they have like data on where they're serving, where the ball's landing. They have like all the coordinates of pretty much everything that ever happens, like where you're standing when you receive it. Like you could do way more interesting stuff than what we've done with the actual raw data that they've got. And you can imagine if you could take that raw data, like often the analysts, they have like an analyst on the commentary, and they give you like a little bit of the analysis, but you can imagine like if you could give this to like an LLM and say, hey, here's all the data points, here's my big like set of data, what's actually happening, and it will probably give you like a way more a way cooler insights into what's going on. But yeah, it's hard to get the data because they sell it and make a lot of money from it as well.
But Mark, very quickly, if we take a sports like maybe F1 or something like providers like McLaren and a few others, they have these readily available data feeds, and they are often fed to their telemetry analytics and those kind of. So we could pretty much reuse that data set as well.
Yeah, I mean, so if you've got the data, I think you could pretty much pick up what we're trying to do here and give it a try.
Absolutely.
Cool. Well, I guess we're at the hour. So thanks for all the questions and thanks for listening. And again, yeah, take a screenshot of this slide if you want to grab the slides, but we'll probably we'll send out these links afterwards as well. And yeah, thanks Denith for joining us as our special guest on this.
My pleasure, and thanks for having me, Mark.
Cool.
And
QR code. There you go. The next one we're gonna go. It'll probably be 2 months, so probably mid-November. We haven't got the date yet, but likely, fair chance we might have Zach and Melvin back again. But we have to see. We try, like, we're gonna demo something. We want it to be a thing that all of you can use. So that'll be the plan. We'll have a look at what is ready at that time. And then that'll be what we'll do. We'll go back to the more feature-based thing. But yeah, I mean, let us know, like in any way you can, like any emails or on Slack. If you like this format, we can see if we can do something similar next on another one. Cool. Otherwise, I guess we'll call it a day. So thanks everyone. See ya.
Thanks so much, everybody.